In this section of unit number 6, we're going to be taking a look at drawing sketches of rational functions. Now, in order to be able to do this, we must understand asymptotes. We're going to be exploring 3 types of asymptotes: the vertical asymptote, the horizontal asymptote, and then I have a new asymptote that I'm going to show you, which is going to be the oblique asymptote. First of all, taking a look at the vertical asymptote. Do you remember that you have a vertical asymptote if you have a non-removable factor which involves a variable in the denominator of the expression of your function? In this case, I have a factor of x minus 2 in my denominator, and that clearly cannot be 0. In other words, when x minus 2 is equal to 0, I'm going to have a vertical asymptote. This means that I'm going to have that vertical asymptote when x is equal to 2. In this example, you can see that there is a factor in the numerator of x plus 2, and that factor can cancel the denominator factor of x plus 2. In other words, what I've done there is I have removed that problematic factor in the denominator. Because I removed it, it's called a removable discontinuity, and I therefore have a removable discontinuity when x is going to be equal to minus 2. I could not, though, remove the factor in the denominator of x minus 3, so that means that there must be a vertical asymptote when x is going to be equal to 3. This means that I can tend towards the value when x is 3, but I may not cross that line. Once again over here, you can see that you are going to have a vertical asymptote because I cannot have a 0 in my denominator. And here, if I had 2x plus 1 is equal to 0, it means that my vertical asymptote must be when x is going to be equal to minus a half. But can you see that the degree of x in the denominator is the same as the degree of x in my numerator? That means that I should be able to find the limit as x tends towards infinity for my function. Now what I'm going to do over here is if I get an answer, if I do find a limit, that means that there is a horizontal asymptote. What I do is I divide every single term, both in the numerator and in the denominator, by the highest degree of x, which I must find from my denominator. As x to the 1 in my denominator is the highest degree of x, I divide all terms, both in the numerator and in the denominator, by x. When I simplify in my numerator, I get the answer 1, and in the denominator for my first term, I get 2. But that second term, 1 all over x, becomes infinitely small as the denominator's value becomes infinitely large. In other words, it's tending towards 0, and so I discount that 1 over x, and the answer is going to be 1 all over 2. In other words, I'm going to have a horizontal asymptote when y is equal to a half. Can you notice in this example, I'm not going to have a vertical asymptote because that denominator is always going to give rise to a positive number. But the degree of x in the denominator is greater than the degree of x in the numerator. This means that I must find the limit as x tends towards infinity, and this will give rise to my horizontal asymptote. This means that in the numerator, if I divide x, I must divide it by x squared, and in the denominator, I take both of those terms and I divide them both by the highest degree of x that I found in the denominator. The numerator cancels to 1 all over x. The first term in the denominator is 1. As the number in the numerator 1 all over x tends towards 0, I've got 0 all over 1 plus 0, which means that the limit is going to be 0. This means that there must be a horizontal asymptote when y is equal to 0. Let's just check again. Can you see that there must be a vertical asymptote over here? Because this factor in the denominator cannot cancel with the expression in the numerator. So in other words, the vertical asymptote is going to be when x is equal to 1. Now, if we had the degree of x greater in the denominator than it was in the numerator, we found that it helped us find a horizontal asymptote. Take a look over here. Can you see that the degree of x this time is greater in the numerator than in the denominator? In this case, this is going to help me to find my third type of asymptote, which is my oblique asymptote. And we'll discuss these in the next video.